Hey guys, this is Ankit and welcome to the Google Cloud Platform Task Series. We are doing a list of basic tasks to get ourselves familiar with Google Cloud Provider, that is GCP. We are following the DevOps Engineer and SRE learning path, also available at cloudskillsboost.google/paths. You can always refer to my repository, thecloudterminal01/learn-devops to get more details. For today's task, we have the following objectives. We will create manifests for persistent volume claims for Google Cloud Persistent Disks. We will mount Google Cloud Persistent Disk PVCs as volumes and pods. Use manifests to create stateful sets. Mount Google Cloud Persistent Disks, that is PVCs, as volumes in stateful sets. Finally, we will verify the connection of pods in stateful sets to particular persistent volumes as the pods are stopped and restarted. The total amount of time we will be spending will be around 12 to 15 minutes. So let's begin. Before we move on to our first subtask, let's check the Kubernetes cluster which is already created. We will see that a cluster with name standard cluster 1 is already created and it's in zone US Central 1A. Let's see whether we can access the cluster directly. We cannot access the cluster as of now because we have to set up our Cloud Shell to be able to access the cluster. For that, we will be running these commands. Let's set my zone environment variable to US Central 1A. Let's set the cluster my cluster variable to standard cluster 1. This is for configuring tab completion for kubectl command line tool. And finally, configure access to our cluster for kubectl. Now if I execute kubectl get nodes, I should get a proper output. Let's move to the next part where we will be cloning this repository, Google Cloud Platform Training Data Analyst. Let's wait for this to complete. The repository is cloned. Let's execute this command to create a soft link as a shortcut to our working directory. Now if we execute this, we should be directly in this directory. So let's go to this /storage, and these are the files for our lab. We can also open these files in the Cloud Editor, which is already open. So let's go to this directory and open storage. First, we want to create a persistent volume claim. For that, let's go through this file. Here we are creating a persistent volume claim with the name hello web disk. The access mode is read write once, and we are requesting for a storage of 30 gigs. So let's go back over here and see whether we have any existing PVCs. We don't have any PVC, so let's create one. PVC is created and it is in pending state. Now let's create a pod which will be using this PVC. So we will be creating a pod with the name PVC demo pod. It has a container with name frontend. It's using the image nginx, and this is the mount path. This is the name of the mount path, and here is the place where we are specifying the claim name, which is hello web disk, which we defined over here. So let's check whether any existing pods are there. In default namespace there are no pods, so let's create one. It's created. Now it's in pending state, and if we execute PVCs, we will see that our persistent volume is now bound, and even the container is in container creating state. Let's wait for a few seconds and it should be up and running. The container is up and running now. Now how do we validate that the pod is using the PVC? For that, let's exec into the pod using sh, and let's create a file in this directory var www.html. Let's see the contents of this directory first. We have a directory with name lost and found over here already. Now let's execute this command to create a file, and again let's execute this command to see whether our file is created. It's created, but it does not have execute permission, so let's execute this command as well to give it execute permission. Now we have execute permission for the file. Let's exit. Now if we delete the pod and recreate it again, the new pod should already have a file with this name index.html in var www.html directory. So in order to validate that, let's delete the pod. The pod is deleted, and if we see that the PVC is still there, let's create the pod again. Pod is in container creating status. Now it's running, so let's go inside the pod using this command, and let's see the contents present in this directory. As we can see, the file is already there, and this completes our subtask. Let's move on to our next subtask, where we will create a stateful set with PVCs. Note that I have already deleted the PVC demo pod. Let's first examine the statefulset-demo.yaml file. So in this file, we are first creating a service. The name of the service is StatefulSetDemo service. The target port for service is 9376 and port is 80. It's listening on protocol TCP, and we will be creating a load balancer type of service. So this is our stateful set. The name of the stateful set is StatefulSetDemo. Selectors for this stateful set would be app:"myapp." Will be having 3 replicas, and we are using the image of Nginx for this stateful set. The container port would be 80. The name of the port is HTTP. It has a volume mount. The name of the volume mount is HTTP web disk, and the path is /var www/html. Again, the volume claim templates, these are the ones we are creating a claim for this stateful set with the name hello web disk. The access mode is read write once, and we are again requesting for 30 gigs of memory. So let's go ahead and create the stateful set. the stateful set is created. So if I run kubectl get pods, we will see that we have 2 pods as of now, and we should have 3 pods because we have 3 replicas configured in the stateful set. So all of the 3 pods are now ready. We can execute kubectl get PVC to get the corresponding PVCs for the pods, and we can also execute get stateful set to get our stateful set as well. And this is the information when we describe our stateful set. Now let's validate the persistence of data inside stateful sets. For that, we will use the same example. We will exec into the pod using sh. When we execute this cat command, we should see that the file does not exist because we have not created the file yet. Let's check the contents of the directory. It has only lost plus found folder. So now let's create the file and let's see whether the file is created. The file is created now. Let's exit from the pod. Now if we delete the stateful set demo0 pod, it should get recreated again, and the new pod should already have this file var www.html index.html. So now let's delete the pod. The pod is deleted. It should get recreated, and it is in container creating state. Now it's in running state. Let's exec into the pod. Now let's see the contents of this directory, and we see that the file is already present. So this completes all of our subtasks. That's all for today. See you in the next video.